Okay, this is ellipses part 4, and we're going to talk about ellipses where the center is not the origin. Okay, so this is one form for an ellipse where the center is not at the origin. This is one, it's got x minus h, that quantity that's squared, and it has y minus k as a quantity that's squared. And just like with the circle, h and k are going to give you the coordinates of the center. So the center will be at the point h comma k. And so when you're looking at it, you can kind of just look here, and whatever the opposite of that number is h, and whatever the opposite of that number is k. Remember, a is always greater than b, so in this case I have the a with the x, so that tells you that the major axis is going to be horizontal. It might not be the x-axis because we are moving the center, but the major axis, so it's longer horizontally. Now, if they want the major axis to be vertical, then the form would look like this. Okay. It looks practically the same. It's always going to be x minus h squared. So whatever is with the x will give you the x coordinate of the center. And then same thing for what's with the y, that'll be your k value, and that'll be the y coordinate of the center. If a is larger than, well, a is larger than b, and if that is with y, then your major axis is going to be vertical. It may not be the y-axis, but it will be vertical. Okay, now a couple quick problems. All right, this one says graph and find the foci. Okay, so when you look at it, you can see it's not just an x squared up here, just the y squared. It's that whole x minus h squared and y minus k squared. Okay, so in this case, h is going to be -7 and k is going to be +5. Remember, you can think of it as being the opposite of that number and the opposite of that number. So that will give us the center being -7, 5. Okay, and so if we go to graph this, we'll need to look at the a and the b. So in this problem, a squared is 100, so that leads us to a is 10. B squared is 64, so that gives us b is 8. And these are kind of the directions that you go out from the center. So we'll have to plot the center here, and then a is 10 units either direction from the center to get to the vertices, and a is with x, so the major axis is not the x-axis anymore, but it's horizontal. Okay, so what does that look like? All right, so here's my graph, and this point right here is -7, 5. So that's my center, all right? And I said that a was 10, so I'm going to go 10 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'll bring me here to 3, 5. That's a vertex. All right. And then if I go 10 the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That will lead me to another vertex. And that'll be -17, 5. All right, so you can see all three of these points have the same y coordinate, so they're on a horizontal line together. Now, we also knew that b was equal to 8. So from the center, you go up 8 points, 8 units, and down 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. And that'll be a co-vertex there. So that'll be -7, 13. This one. And then go down 8, 1, 2, 3, 4, 5, 6, 7, 8. And that'll be another co-vertex. And that'll be at -7, -3. Okay, and so then if you draw in your ellipse, I'm not very good at drawing these by hand, but that'll give you the basic idea of it. Okay, now, so this is the major axis here. And then there's the minor one. Okay, now as far as finding the vertices, the foci, you can just use the 10 and the 8. Remember, we have this rule that c squared is equal to a squared minus b squared. So we would do 100 minus 64, which will be 36. So that gives us that c is 6. So if you go back to the graph, and I really like to look at the graph. Remember, this one's the major. So the foci will be on the major one. So you would go out 6 units from the center. 1, 2, 3, 4, 5, 6. So that's going to be a foci, and that appears to be negative 1, 5. And then I will go 6 this way. 1, 2, 3, 4, 5, 6. And there's another focus. And so that'll be negative 13, 5. All right. That would answer that. And then just one last thing. It didn't really ask us for the eccentricity, but that is c divided by a. So if you do 6 divided by a is 10, you will get 0.6. And that would give you the eccentricity. So it's a little bigger than 1/2. Okay, one other one. Okay. All right, now this one, they didn't give it to you exactly in standard form. So that's why I wanted to look at this one. This one has coefficients. So you've got your x minus h squared here and your y minus k squared here, but you've got this 8 and the 7 in the way. And then over here, more importantly, you don't have the number 1. You have to have the number 1 for standard form. So take whatever that number is and divide both sides by it. In this case, we'll divide by 56. So you're going to have 8 divided by 56. So you're going to end up with 7 under here. And then 7 divided by 56, when you simplify, you'll be dividing by 8. Okay, so now that's in our form, and you can see here's the a squared, that'll be 8, and it's underneath the y, so that's going to tell you the major axis is vertical this time. And then b squared is 7. All right, so for graphing purposes, we'll take the square root and we'll get a and b, and they're not nice perfect squares, so approximately 2.8 and 2.6. Okay, so if we go to the center, which is going to be positive 3, negative 2. All right, so that would be about here. Well, it would be there. Okay, so the a value was approximately 2.8, so almost 3. Remember, a is with y this time, so that's a vertical thing, so you would go up 2.8. So 1, 2, not quite 3. We're close to it. And down 2.8. 1, 2, 2.8. Okay, so those would be vertices. And then to find the co-vertices, you're going to go 2.6 in a horizontal way from the center. So about 2.5. 1, 2.5. 1, 2. Right, now you can see not that big of a difference. One way it's 2.8, the other is 2.6. So this ellipse is fairly round. It's not exactly a circle. All right. If we found the eccentricity, if we did E and C divided by A, that would be 2.6. Oh, I'm sorry. C is 1. Here's my calculations for C. A squared minus B squared. So it would be 8 minus 7. C squared would be 1, and C would be 1. So then if I did the eccentricity, that would be 1 divided by 2.8, which is approximately 0.4. Okay, so you can see that's smaller than 1/2, and it's closer to 0, and that's why the ellipse is a little more round.